Linux knowledge is seeping away in our industry. Youngsters from the universities are becoming, no-code, low-code experts, can hardly do CLI stuff anymore, command line interface. So it's really interesting, basically, to ask a question like, hey, how do I add a user? How do I add more compute nodes? How do I do this? And get something in return. Well, CloudFest, hello. Thank you for waiting. I mean, it's been a long time. Thank you for attending. Thank you for not falling asleep, basically, because it's after 4. So I can only imagine that you guys are here and excited. So my name is Simon, hailing from Amsterdam in the Netherlands, part of ClusterVision. And today I'm going to talk about a bit of the open revolution in high-performance computing and AI. So ClusterVision is part of the Taurus Group. I'm talking a little bit about the Taurus Group here. So we are a fully privately owned group of companies with 11 entities globally. So during CloudFest, we're representing a few of our companies here. So we're talking about Taurus Europe, which is an IT distribution company selling IT enterprise components. Circle B is an open compute provider, also an open compute infrastructure as a service provider, also hailing from the Netherlands. Then we have Taurus Renew, basically. Taurus Renew does IT asset deposition, cleaning out your data centers once the infrastructure is obsolete, selling them as a broker, essentially, and also offering other services around it. And today, we're talking about ClusterVision. So what we do, we are a company specialized in high-performance computing. So we've been doing that for over 20 years. We're fully privately owned, like I mentioned. And basically our specialty is to work around the application stack of the end user and design a high-performance supercomputer around it, basically. So we understand how the application behaves, how it works, and we designed products from the ground up, doing also our own software stack, fully open source. And this is what I'm going to present to you today. A fully open source software stack. And I hope that we have a lot of members here and in the audience who are software developers and willing to assist us in developing our product even further. And that's TrinityX, our open source software products. So where are we using TrinityX? And I come to a few minutes what TrinityX is all about. But where are we using it? Well, in numerous applications. We're talking about maritime, engineering, we're talking about public institutions, universities. You can see a few of them on the screen. We have around 90 installations globally, with our biggest installation is about 15,000 compute nodes in one cluster. That's quite a few petaflops, essentially. So let me see. So a typical design of a supercomputer. I mean, we're here in a hosting convention, so I thought, it's interesting to present a different line of work, a different branch, basically. So a supercomputer typically is infrastructure, as you can see. So infrastructure, we work with master nodes, and a master node typically holds the image, which then is going to be distributed along tens, hundreds, thousands, or 10,000s of nodes. We have login nodes in essence, where the users are being logged in, where the applications are being run. And the infrastructure can be anything. It can be x86, it can be ARM, it can be GPU, it can be compute, it can be anything. We do that over a high-performance interconnect. Usually it's InfiniBand, so we don't care whether it's 100, 200, 400, or 800 gig. Or it can be Ethernet, Rocky RDMA, for example. That's what we typically use. And it can also be anything. So we're completely hardware agnostic. Our software is hardware agnostic, so it doesn't really matter what we use in terms of brand or technology. And to top it off, we use parallel file systems like Weka.io, Vast in some cases, BGFS, and other products like Lustre, for example. So a typical supercomputer also has an operating system. We typically use Linux, Red Hat derivatives. That's what we like to use. And then on top you have a bunch of modules, in essence, which are part of the Trinity stack. So I skip the middle part, because this is what I'm going to talk about. And on top, we have different services, like remote management services, and also the user application stack lives all the way on top of this specific design. And furthermore, cluster management. So this is what I'm going to speak about in the next 5 minutes. So time's flying. So in essence, why do you want a cluster manager for your system? Or for, if you are a cloud service provider, why do you need a monitoring system or a node provisioning system? Well, usually you don't want to run around with USB sticks for every single device. You do want to manage things from a centrally managed location. This is where Trinity basically comes in. So our product is fully open source, licensed on the GPL3 for those of you who are interested in that. So we use Prometheus and Grafana as industry standards, basically for monitoring and also for dashboarding. Luna here is a special mention. So we have the product already in development for over 10 years. It's our own node provisioning, our own image provisioning system. So we're capable of doing tens and thousands of nodes booting in minutes of time. So we use BitTorrent as the underlying transport mechanism. But if you're interested, you can also use wget, HTTP, or obviously HTTPS as well. And a special mention to Open OnDemand, that's a graphical user interface. So what is TrinityX capable of doing? So the node image provisioning, what I spoke to you about earlier, that's really powerful because you can boot nodes within minutes. You can have multiple images. So doesn't really matter about what version. You can do different Linux distributions, Alma, Ubuntu, Rocky. You can tie them to groups. You can tie them to nodes. It's a really, really powerful tool. And plenty stuff to talk about. But my time is pretty limited today. So the monitoring and alert management is something which we also do. It's really interesting. So we use Grafana for that. To do monitoring, to do alert, and we also have AlertX, that's our new alert system, and an honorable mention also for the energy-aware workload scheduling. So energy consumption is more and more an issue, a topic in data centers also these days, and we can do a per job power consumption, power measurement, which is really powerful, so you can really know the output of every single job, every single user, or even the entire system itself. So in essence, no vendor lock-in, vendor agnostic, really important. We support every single accelerator on the market. I mentioned NVIDIA and AMD here, but there are plenty, like Intel, for example, that is supported. Completely free, that's also really important, I would say. So you can go to GitHub, download it, dismantle it, use it as a package, how we package it. It doesn't really matter. And the Open OnDemand, that's something which was developed by the Ohio Supercomputing Center, a university in the US. It's a graphical user interface, so for users. And it typically uses PUNs, a PUN, which is an application. So you're natively running the application basically within the Open OnDemand space. And that's very new in the supercomputing space. It's even, you can even run on a mobile phone, because it runs basically on the cluster itself. Furthermore, a bit of our roadmap. I won't bore you with all the little details. A few honorable mentions, obviously. We would like to have a more aware community. So this is also an interesting community for us to tap into, to help us develop the product, steal some of our technology, or lend, so to say. We're also like to get in touch with people who have interesting features for us, where we can say, like, hey, we might be able to integrate it. Cloud cycles, for example. I mean, I bet there are plenty of unused cycles here in the cloud space where we can tap into. A few ideas, for example, where we can basically broker unutilized resources, offer them to our clients in the TrinityX environment, bill it in some shape, way, or form, broker a percentage. These are a few ideas which we have, so come and join us, come and talk to us. And what is really interesting is, yes, we also have a large language model, like the vast majority of companies globally. So what we do different is we have more than 25 years of experience in the high-performance computing industry. So we gather all our knowledge in our own knowledge base. We combine it with the API from OpenAI. And in essence, we have an extra engineer sitting on your desk, basically. Which we think is really powerful because Linux knowledge is seeping away in our industry. Youngsters from the universities are becoming, no-code, low-code experts, can hardly do CLI stuff anymore, command line interface. So it's really interesting, basically, to ask a question like, hey, how do I add a user? How do I add more compute nodes? How do I do this and get something in return? So this is something which we are working on, which will launch somewhere later this year. And again, you can do fully managed support completely by yourself, no money, do it yourself, or you can contact us for enhanced or proactive support if this is something which is interesting for you. And with 19 seconds left, I would like to thank you for your attention, for not falling asleep, for having an interesting convention. So thank you for your time, and enjoy your convention. Thank you.